Hi, thank you for having us. We're Team 787, or IoT-based localization of acoustic sources. My name is Michael Shepard. I'm the team leader.
I'm Cy. I'm the software lead.
Hi, I'm Sharon Joseph. I'm the QA engineer for the team.
I'm Sean Scott, testing engineer.
Hi, I'm Imelda, and I was the electrical engineer.
So the Air Force Research Lab has tasked us with building a system of devices capable of performing acoustic localization in a given environment, whether that's in a closed room or an open air. Our current solution involves commercially available off-the-shelf products that are capable of determining the direction of arrival, the magnitude, and the timestamp of an incoming sound signal. And by using two or more of these devices, we're able to use the directions of arrival to triangulate the location of an object within a given environment. And hopefully with the end goal next semester of being able to configure different configurations for the customer to suit their needs. And with that said, I'll pass to Cy for the software.
So as far as the software goes, we're going to have it in 3 separate sections. So our hardware devices consisted of a Raspberry Pi Model 3, and then we have a off-the-shelf USB speaker array. So essentially, on the Raspberry Pi itself, we have the Python script, which is reading data from the microarray and streaming it to our backend server. So our backend server will probably be written using Node.js, which is a JavaScript runtime. And so we'll have that hosted somewhere in the cloud. We haven't really ironed out the specifics yet. And so basically the Raspberry Pi will be streaming data that is timestamped, has the angle of arrival, and has the amplitude of the noise. And then that'll be processed by our backend server. And we will run calculations on that data using angle-side-angle geometry and store that into our database. For our database, we chose to use PostgreSQL, which is an open source relational database. Then as far as the user interface, we're going to use a JavaScript library called React.js, which is a component-based user interface library, which makes it super easy to configure basically an interface that can be changed from user to user. And that was one of the requirements that our clients wanted. So basically, our goal for the next semester is to build out this entire software stack and make sure it's running properly, and make sure that when a user logs into our web application, they're able to see exactly what our device they're listening to and see the position that is calculated based on the data that we're receiving. Any questions?
On the user interface, will there be context as to, like, a map as to where the devices are located, so you have some idea?
Yeah, so for our initial configuration, as you can see on the picture to the left, our initial configuration will be to have 2 devices, and they're going to be located against a wall, and they'll be directly perpendicular with each other. And so, but in the future, we'll be providing like a settings page where the user can define like where they'll place the device in a room, and that will change how we calculate the position of the sound source.
So they also kind of have to define a way to define what the room looks like as well, right?
Yeah.
Did you have to place the speakers that way with respect to the object? I mean, I'm just wondering, could you have more than 2?
Yes, for initial proof of concept, we just used like 2 on a wall because it, kind of allows you to characterize your device as a simple system. But you can build it out with any number by just figuring out which devices, like if the sound is in relation to these 2 devices, you understand those are the 2 best ones to make that calculation. And then you'd be able to extrapolate that to different configurations.
But the demonstration will be with just 2?
Yes.
And they are halfway through the project,
Yeah.
so they still have 1 semester.
So is the intent for this to be an interior room kind of a system, or an outdoor, open environment?
We're trying to do both. Yeah, our customers specified it should operate in an indoor setting and an outdoor ambient setting. Obviously, with an indoor setting, you're dealing more with echoes, like within this room right now, the sound's bouncing off the walls, but also the difficulties in an outdoor environment is typically a lot more noise, like ongoing traffic and shadowing effects as well.
I'm not at all familiar with this arena, but how, if you had a gunshot or something, how would you know how far away it was versus, I can see directionally you got it, but how far away it is? What kind of information is in the audio signal that tells you the distance?
So each of these microarrays is like independently capable of calculator called time distance of arrival. And so each one is going to figure out like, oh, we got it at this time. And by using the timestamps, we use that delta to figure out like, oh, if it hit this first, then obviously based on the angle and the time difference, you can figure out the distance.
Do you know how each one of these off-the-shelf products determines angle?
They're independently 4 microarrays, and
Four.
and like I said, so that like each one of them is a self-sustained kind of SoC that determines the angle itself.
How critical is it that these 2 devices, or 20 when you're done with it, are perfectly aligned or parallel with one another?
Again, you can, based on like the configuration that you have, you can just, you have an algorithm essentially that decides which 2 are best positioned to make the calculation based on the direction of
I'm
the
thinking
rain.
more about the build. If you have if you're putting them on a wall, are you assuming that the wall is flat? Whereas the wall, if the wall was off by a ½ degree, would that influence the performance of the system in terms of accuracy to your 1 square meter? And if you say, yeah, it matters, then is there a need to somehow have some kind of calibration routine that you stand 100 meters away and you say, I am 100 meters away, what did you get? Where do you think I am? So you're doing some kind of calibration routine on the system.
Yeah.
So are you saying that we would have to find out that you set the 2 arrays apart and you get a physical dimension, and then we do like a test tone, and then we compare whenever the first one's sent out and the receiving one, and we can find out the distance and find out, oh, we set at, I don't know, 1 meter apart, but it's picking up at 1.05. Is that what you're kind of
I'm
recommending?
thinking that if you have 2 sensors, I think your fundamental assumption is that they're parallel to one another. And
So-
if they were askewed from one another, if they're off by 2 degrees or off by 20 degrees, or
Mhm.
one's this way, if they're different, then the reference assumption is that they're parallel. And if they're not parallel, you're going to have an error. So you probably need to have some kind of calibration routine that defines a known so that it'll then calibrate the system.
Yeah.
And then you deal with that calibration on an ongoing basis.
That's
Okay.
definitely a consideration that we've thought about, and one of our future plans is not to just have like a peripheral approach to where we place things, but maybe a centralized one. So that way you're just figuring like ultimate distance from a central location. So again, you have to understand, like you were pointing out, like the layout of the room essentially, but we're considering that maybe different orientations or configurations, like a centralized approach, might allow the customer to approach those different configurations better.
Mm.
Okay, let's thank the team.